First thing is to look at the sort of the instructions for solving these. There's two differences from what you've done with the multiplying. Okay, the first is instead of dividing, anytime you're working with a division problem, what we're going to do is use the fact that dividing is equivalent to multiplying by a reciprocal. And so what we're going to do is we're going to take our second fraction, we're going to invert it, and we're going to multiply it by, or multiply it to that first fraction. Okay? So we're going to invert and multiply. In this process, we're going to go ahead and perform the steps that you would when you multiply. Okay? So we're going to factor it as we do this step. So the first part here is to invert. We take our original, the equation on the, or the fraction on the left. We leave it exactly as it is. We are going to factor it though when we write it out. So we have q to the fourth. Now notice that this factor is written in the wrong order. It's not in standard form. So if you reorder it, we would have a negative as our leading coefficient, which again we don't want. So what we're going to do is we're going to take out a negative sign from these two terms. The 2 becomes a negative 2, and the negative q becomes a positive q. And so this would be the factored form of that first fraction. Now instead of dividing it, we're going to multiply by the reciprocal. And the reciprocal means you flip the fraction. So the factors that were in the numerator, 9 and q minus 7, are now going to be moved to the denominator. And the factors from the denominator, q squared and q minus 2, get moved up to the numerator. Okay, so that is the first step. Once you get through this step, you go ahead and complete the process of multiplying. And the process of multiplying involves canceling any common factors. So here, the q minus 2's cancel. These two q's cancel with 2 of these, leaving 2 down here. And that's all that cancels from this. Remember, and so the solution, the simplified form for this would be q minus 7, or q plus 7 in my numerator. Now I'm also going to move my negatives. I will tend to move my negatives up to the numerator. And in the denominator, we have a monomial factor of 9 and q squared. And then our binomial factor of q minus 7. Thank you. Okay, so this would be our simplified form. Okay, once we get to this step, we then look at the second way that this is different than multiplying. Okay, and the second way is when you look at your domain restrictions. Okay, so the domain restrictions are going to be the same restrictions that you see when you multiply. Okay, so any factors that get canceled from the denominator. Okay, so if you have any factors from the denominator that get canceled that are no longer apparent in the simplified form, you have to include those. So here we see that this q minus 2 gets canceled, so we have to account for that. So q can't be 2. Nothing else cancels completely from the denominator. There is a q that cancels, but it doesn't cancel completely. So the only restriction we see from this first rule of finding the domain restrictions is the canceled factor 2, okay, or the 0 associated with that canceled factor. The next one that you have to consider is the one that's new, and that is not only do you have to consider the canceled factors in the denominator, but because the original fraction, its denominator, included what gets moved to the numerator of the inverted fraction, you have to take any factors in the inverted fractions numerator that didn't get canceled. Okay, so the factors so any factors in the inverted fractions numerator that remain and did not get canceled will also have to be restricted. And the reason for that is that these factors right here, in this case both of them got canceled, but they started out in the denominator of their own fraction, which means if one of those was equal to 0, you'd have an undefined value. Division by 0 can't happen, so you have to restrict those as well. So in this particular case, we just have this one restricted value for Q.